Hey guys, welcome to DSA-n-Design. Today we will look at very important question which is actually very important from the interview point of view for your DSA round, right? So DSA round, which is basically about find a cycle within the linked list, right? So cycle detection, right? This is about how to ensure that we have a cycle within the linked list, right? So it's about the cycle detection, and we will try to see what exactly it means, right? And then how actually we can solve this question, right? So let's say, for example, I have a linked list. For example, I have couple of nodes here, for example, like this, and so all of these nodes, for example, the value is 2, 3, 5, 8, and 20, right? For example, in this case, you can see the last node actually, this actually pointing to the null node, right? And this is my head, right? So in this case, there is no cycle, right? But for example, if in the same kind of no cycle here, right? This is basically no cycle, correct? But for example, let's say I have another linked list like this, and I have here one more, and we have something like this, basically like 2, 3, 4, 8, and 10, right? And this is pointing to this, and this is again pointing to this particular node. Now you see there is a cycle here, right? You can clearly see this is a cycle, right? This is a making a cycle, or this is making a loop basically, right? And in this case, we will never reach to the last node. Like we don't know which is last node, right? In this case, we know that this is the last node, correct? This is last node because it is pointing to null. But in this case, I don't know because it's actually going in the cycle and cycle, and which is actually going in the loop, infinite loop, right? Infinite loop. So what our question is basically to find whether there is a cycle present in the particular given linked list or not. Given a head node, right? Given a head node, find out whether there is a cycle present in the linked list or not. This is the simple question. All right. So let's try to understand the approach basically, right? So if you look at this very carefully, what exactly we can see it here is, can we say that if I continue, if there is a cycle, right? If there is no cycle, first of all, the last node is basically going to be null, right? But if, for example, there is a cycle present, in that case, what will happen is basically I will be repeating the node, which means I have traveled this particular node before. I will again and again actually, repeat this particular node, right? While I traverse the linked list, right? In this case, this is my repeated node. So can we say that we can use one technique wherein I can actually find if I actually traverse again and again on the same node, then I can say, oh, already I traversed to this particular node. So can we use some sort of hash set, right? Hash set of node basically, right? And this is something that I can use, right? Hash set. What exactly we can do? We can actually continue to travel here, right? Continue to traverse until I find maybe my node as null, right? If it is null, then fine, it will actually say, if I do not find the null, in that case, I'll continue to traverse and I keep checking, okay, hash set contains, right? I will keep adding and I will say hash set contains this particular node or not, right? If it is containing, then I say true, return true, and I'll come out of loop. Something like that. This kind of approach, right? Correct? We can do something like that. But let's say I say that in this case, we are actually consuming some space, right? So space complexity, if you see, I'm actually consuming space complexity order of n, is it? Because I might have to traverse at least approximately all the nodes to find out it, right? So, but I'm actually storing all this in a hash set, which means I'm actually consuming extra space, which is in form of this hash set, right? But my question is basically, my ask is I don't need to use any extra space. Like I have to solve this problem, right? Without using any extra space means space complexity should be order of 1. Okay. constant space, right? So how can we solve it, right? How can we solve it? So there is a very beautiful, this is the way one, by the way, right? Using the hash set, right? So one kind of, I would say way one was basically using hash set, correct? Which will actually having the space complexity as order of n, and time complexity is also order of n, because I am actually traversing all the nodes, right? Now way 2, what is the way 2? This is very famous, and this is what I am going to discuss basically here, right? So in way 2 we can use something called Floyd's Floyd's cycle detection algorithms, right? Cycle detection algorithms. This is the one. And here, what exactly we see, we will appreciate it. But this is basically, we are not using any extra space. This is actually order of n, and TC will be order of n. Basically, SC will be order of 1 and TC will be order of n. Something like this, we will use it. So let's try to understand how exactly we do this, right? Floyd's cycle detection, and this is the very famous, and this is generally the way to find out a cycle. We don't go generally for the hash set way, because here we have the space complexity involved. Here there is no space complexity involved. That's why we use this, right? So let's try to understand this. So what if I have, let's say, this particular node 1, 2, 3, 4 and 5, something like this. I have this particular node, and this is pointing to this is pointing to this, for example, right? Now if I can say here is, let's say, value 2, 3, 5, 8 and 10, right? Now I start traveling from here, right? Can I do one thing in Floyd? Can I make so what Floyd says, right? Floyd says that we will maintain a two pointers. One will be slow pointer and other one will be fast pointer, right? Whatever we have seen in, you remember when we were actually looking previously about the finding the mid node, right? That's where we actually use slow and fast pointer. Similar way we will use here as well, slow and fast pointer. So I'll point initially, this is my head, right? So initially my slow and fast will be pointing to this, and my slow will be actually moving two steps. Sorry, slow will be one step and my fast will be moving two step basically, right? Two step, next, dot next. All right. What will happen is there will be a point when slow and fast will be same, because we are actually going in loop and loop, right? In that case, there will be definitely a time when slow and fast will be meeting at one point, right? And if I find, I continue to travel, and if I find if slow equal to fast, and then I say yes, cycle is fine, return true, correct? I'll say return true, cycle is found. So can we just check it here, right? So let's say slow and fast. So slow will be moving one step, fast will be moving two step, right? Now so slow will be here and fast will be basically here, right? Correct. Now okay, this is gone. Now slow will be moving one step here and fast is here already, which will again go in the cycle, so it will actually moving two steps, so 1 and 2, so fast will be here. You see beautifully, slow and fast, there is a point when slow and fast should be pointing to one particular node, right? And if this is the case, and then we say that there is a cycle detection, very simple, right? So can we actually use this Floyd cycle detection method, right? So let's try to understand how we can code it, right? First of all, let's go to ID directly, that will make more sense. So I'll say public static, what exactly we want to know? We want to say there is cycle available, cycle is there or not. So boolean, I'll say is cycle present, right? Cycle present, and what I'm going to send is I'm going to actually take an input as a head node, right? Now I'll do one thing. I'll make node. I'll say slow equal to head, and again I will say node fast equal to again head. Correct. Fine. This is what we have seen. Now what we will do is we will actually say one more variable, which is kind of is cycle. which means it will tell initially I'll say false. By default it is false. I'm assuming that there is no cycle, right? But here I will say boolean. This is my boolean, and each cycle is a variable. I'm initially setting it to false, right? Now let's start traveling. So what I will say, what I will do actually, I will continue to travel, and I will use the same condition that we have used for finding a mid node, right? So I'll say fast dot next is null, and fast dot next, okay, fast dot next, correct, is null, is not null, right, until this condition is true. Okay, if you are not sure why we are putting these two condition, I would suggest please go and watch the video where we are actually trying to return the mid node, right, of the linked list. But yeah, I hope that this you understand, right? So fast pointer, if it is, because since it is actually traveling to two steps, right? So in one of the case, right, it will actually move to, I mean, the next immediate kind of next pointer might be null, or there will be case where after traveling two steps also I might get null, right? If that is the case, which means I'll come out of it, and in that case I will kind of say that okay, there is no cycle, right? If there is no cycle, either of this condition will be false actually, and I'll come out of it and I'll say is cycle false actually. I will return that actually. But there could be case where cycle is present. In that case, my slow and fast will be meeting at one point of time, right? But before that, I will just say I will just move my slow by one step, fast by two step, by next, perfect. If my slow and fast are meeting at point, then I will just say each cycle. I will set it to true because I mean, there is a cycle, right? And in that case, I'll just break out and break and come out of it, come out of this while loop itself, right? And then I will just return it here actually each cycle. Okay, if I can just show you this code, basically what it actually going to do, right? So if I can just walk you through, yeah. So for example, yes. So for example, there is a linked list where I don't have kind of okay. Let's do one thing, guys. Let me just one second. Okay. Let me explain you a little bit kind of from this point of view. Like we will actually do the dry run, right? So let's see. I have this node 1, 2, 3, and 4. Fine. For example, this is my linked list. Case number 1. When I don't know whether there is you know link. I mean there is no cycle. In that case, what will happen is this is my head, and this is fast and slow both. Correct. Now let's say I am actually moving. Slow is actually moving one here. Fast is moving here. Right. Now again, there is a while condition. You can see it here, right? So while condition. In the while condition, we are checking fast dot next should be not null, and fast dot next also should not be null. Now in this case, if I see fast dot next is null, no, it is not null. Fast dot next, which is actually null, because fast dot next is this one, but fast dot next is actually definitely null. So in this case, I will say f dot next equal to false. Correct. If this is the false, this is false, then I'll come out of the loop, and what I will do is I will not actually go inside the while loop only. I'll immediately come out here and I'll return each cycle. Each cycle is initially set as false, which means there is no cycle basically, right? So it will return false itself. The function will return false itself. Now let's look at the second case. Second case where I have a linked list, right? Linked list 2. Now I have these nodes. Simply guys, let's take this. Okay, they are actually like this, and I am pointing to this. So 2, 5, 8, 10, and 20. Okay, all right. Now we know that there is a cycle because this last node, this node basically 20 is pointing to this. Now let's try to understand this basically how exactly it is fitting into this. So this is my head node, and obviously slow and fast both, right? Now slow will be moving here, fast will be going to two steps. Now slow will be coming here and fast, oh sorry, slow will be here and fast will be actually going to two steps. So fast will be here actually. All right. Slow will be moving one step, it will come here, and now fast will be two step. So fast will be one and two, fast will be actually here. Now again slow will be coming one step here, right? And the fast will be what? Fast will be two step here. All right. Now slow will be one step here, correct? And fast will be two steps. So one and two. Here actually they are actually meeting and they are saying okay, because since fast dot next will never be null and fast dot next also will never be null because it is going in the circle and circle, right? So there is always, so this if you see, this particular condition is always true in case of a cycle. Okay, so this condition will be only false, one of this condition will be only false when there is no cycle, right? It is a normal linked list, there is no cycle. If there is a cycle, this condition is always true, which means fast dot next and fast dot next will always be kind of not null actually, which is always true. So only way to come out of this is basically when slow and fast meet together, and this condition will ensure that okay, there is a cycle and then you break out, and here before the breaking out we are actually setting is cycle equal to true, correct? Which means there is a cycle present. Hopefully it is making sense to you, right? These two examples, right? When we have cycle, but we don't have cycle. Now quickly what we will do is we will try to run it, actually this one, right? So each cycle, what is this? Let me run it quickly and then I can actually okay, so I want to do one thing. I want to just print it true or false, right? That's it. No, I don't want anything else. I can just say head, correct? Can I run this? Do we have any cycle? No, I think we have 5 nodes and there is no cycle. So it should ideally return, what? It should ideally return all the, let me just, why it's not running? One second, I think it ran, but I can see it here. Okay, it says false, right? There is no cycle. The moment I say, okay, let my last node n5 also point to maybe n2, correct? Which means linked list will be actually the last node will be pointing to something like this, no? Something like this. Let's say this is n1, n2, n3, n4, n5, and this n5 is here. No, n5 is again pointing to n2 actually, something like this, which means there is a cycle, right? This is what we are doing here, right? So now there is a cycle for sure. Can I run it? If I run it, I think this function will go infinite loop actually. This printing will be doing infinite. Let's see. You see, it's going.